Hello, welcome. Today we are going to look at another application for locus, and in this case we are going to draw what we refer to as a cycloid. Now we got to understand the meaning of a cycloid or a definition. Now a cycloid is a locus of a point on the circumference of a circle which rolls without slipping along a fixed line. So we are going to draw a locus that is going to move on the circumference on a straight line without slipping. That is from a fixed line without slipping. Now the question that we are going to use is draw a locus of a point P on the periphery of a circle which rolls on a straight line path. Now take the circle's diameter as 60 millimeter. So what are the steps here? One, we are going to draw a circle. We are going to draw a circle. Now in that line we are going to have a circle anywhere along this line. Our circle is of radius 60, so we get to look at our ruler and pick our distance 30, that is 3 centimeters. Starting from anywhere on this line, we can pick our center and draw our circle. This circle here is of radius 60, not radius 60 but radius 30, diameter 60. That's the first step. Now we locate our point P, and before locating our point P on the circumference, we can first of all draw the two center lines of the circle. You can have that, then we complete this to give us. Now let's say this is our point P that is going to be moving one, or the next step we are going to do, we are going to draw a straight line from P, horizontal line from P equivalent to the circumference of our circle. Now the circumference is given by pi d. If we calculate pi d, that is 22/7 multiplied by our diameter, which is 60, we get our circumference as 18.8. I've calculated that. We are not going to calculate, so we are going to draw a straight line from point P, the horizontal line. Then that line should be equal to 18.8, that is the circumference. So we measure our circumference as 18 point. Let's use this one. This is then let we continue draw this straight line because we want to get our distance. So we can now measure 18.8. This is 18.5, 0.6, 0.7, 0.8 should be here. So this is the point, that line. Now the next thing, we are going to divide our circle into 12 equal parts. Do you know how to divide? We get to take the radius of that circle, we stand at it with it at every point of intersection between the circumference and the center lines. We make those arcs as I'm doing. Then we do correspondingly join to give us the divisions. So this arc and that corresponds, this one and this corresponds. So it's like we have opened here and drawn the circumference. We open the circle to give us a straight line. Then we have our center. We can refer to it as C. Okay. Next thing, after you divide it, we can number as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the last one is 12. The next thing is to divide this straight line, the one that we've used the circumference to draw. We divide it into 12 equal parts. How do we do it? The normal way is by having another straight line at any given angle from this point P on the periphery and have 12 divisions on that particular line. We can have 12 divisions on that line. Let's have the 12 divisions. Starting from P, we have 1, 2, 9, 10, 11, and 12. Then we connect or join the last point to the last mark from here, this point here. Then we are going to move those points to be able to fit on our line. So we first of all realign. This one we all need to know how to do it. So we first of all realign and start transferring the points back on our straight line. So the first one, remove this. We again move this. We move that. We move this. Then lastly but not least, now once you have moved, we can number them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the last one is 12. Because as you can see, we started with 12, 1, 2, 3, back to 12. Those are 12 divisions. The next thing we shall do is we are going to draw vertical lines from that line, the divisions, the points vertically upwards to meet this line through the center, because this line here we just draw vertical lines. And how do we do it? We still use our verticals and our horizontal edge to draw the vertical lines. So right away from number 1 we can have the vertical line, come to number 2, number 3, number 4, number 11, and last but not least, number 12. We can as well extend this. Next step is we are going to draw straight lines from 1, 11, 10, 2. Those straight lines are parallel to both this and this. So we just draw straight lines first of all from this 12 and 1. Not 12 and 1, but 11 and 1. Just a straight line passing through this point in that manner. Next we come to tenant 2, straight line, then 8 and 4, then 5 and 7, and lastly 6. Now once we have that, what we are going to do is we are going to name this as C, this one as C1 because this is 1, this is C2, this is 2, this is C3, C4, then C5, C6, C. So we need to know how point P, this point is going to move as we move the center from C to C1. If this center moves from C to C1, where will be location of point P? When the center moves from C to C2, where will P located? When the center moves from C to C3 at this point, where will our P be located? So how do we do it? First, we get to know the radius, that is C to P. We take that radius as it is, CP, then move at C1 and make a cut or a mark on line 1. That's line 1. Okay, now the same CP, same radius, come to C2, here it is, make a cut on line 2. This is line 2. Then the same radius at C3, cut on line 3. Same radius at C4, cut on line 4. Same radius C5, cut on line 5. Same radius C6, cut on line 6. Then C7, cut on line 7. Then C8, cut on line 8. Remember 4 and 8 are one line. Then C9, cut on line 9. This is line 9, This is line 9 and 3. Then C10, cut on line 10. Then C11, cut on line 11. Then C12, cut on line 12. So it comes back to the starting point. And what we are going to do, we are going to join with a straight line from right from this point here, there, 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 with a fine curve. So joining the points gives us a cycloid, as you can see. Like point P is taking a path from 12 to 12. That path followed by that point as the circle moves, along the circumference as the circle rolls, gives us what we are referring to as a cycloid. Thank you very much for attending. Consider subscribing, and if possible, share out with your colleagues and friends and anyone that you believe or hope will benefit from my content. Nice time.